Graphing the absolute value functions. So if I'm given the function y equals the absolute value of 4x minus 1, what we want to consider is we're going to consider graphing just the expression inside the absolute value function, which is y equals 4x minus 1. So when I graph this, I am going to think about this as a linear function. My y-intercept is at -1, so I'm going to plot a point at -1. I am then going to use my slope to get another point on my graph, and my slope would be 4 over 1, which is technically thinking rise over run. I'm going to rise up 4, 1, 2, 3, 4, and go to the right 1. And now I have a second point on my graph. So when I graph this, I am going to just lightly graph this because this is not my absolute value function. This is just my linear function. So here's my equation, y equals 4x minus 1. Now to take the absolute value of that, what you want to think about is I can substitute any input value into this function and it'll spit out the output value. But all of these values below the x-axis that were originally an output value of a negative, so example -1, -2, -3, -4, when I take the absolute value of those output values, they are now going to become positive. So this y-intercept of -1 as an absolute value function is now going to be +1. This point here at -2, when I take the absolute value of that, is now going to be +2. This absolute value of -3 is now going to be +3. So what happens is the bottom of this graph that is originally negative y values are now going to become positive y values. So now I'm going to take my point, I'm going to darken this line. These y values that were originally positive are going to stay positive. And then I'm going to take my eraser and just lightly erase everything below that line. So this would be the graph of the absolute value function, y equals 4x minus 1. So now to determine the domain, well, the domain hasn't changed. The domain can be any real numbers. I can still substitute in any input value and it'll spit out an output. What has changed is my y values. The range of this graph is now going to be everything greater than or equal to 0. Okay, again, how would we write this as a piecewise function? So not even thinking about the absolute value function at all. As a piecewise function, I'm going to consider, well, this expression could be positive, which represents this graph. Okay, and in order to get all of these points, what can you say about the x value? Well, my x value, this y-intercept, so if we were to solve this expression for my my x-intercept, x-intercept, my x-intercept would be 1/4. So therefore, all of my x values in this case would have to be greater than or equal to 1/4. How would I produce this graph? Well, this graph is the negative values. Remember, originally these output values were negative. So I'm going to apply a negative to this entire expression. And all of my x values in this case would be less than 1/4. And that is your piecewise function.